post-wildfire disasters, rising construction costs, and future-proofing against climate change, how do we keep our ground solid when everything else seems to be shifting? Today, we're joined by a top geotechnical expert, Joseph McElhany, who's been in the trenches designing solutions for landslides, rock falls, and even post-wildfire debris flows. If you work in geotech, construction, or just want to know why the ground beneath us is getting riskier, stay tuned. This is going to be a risky one. Joseph, can you tell us a little bit about what you do and what keeps you busy?
Yes, well, thank you, Michael, for having me on the show. I really appreciate it. And thank you for having this show. I've watched a lot of your podcasts from other professionals in the industry and a lot of good content out there. So thank you for what you're doing and bringing awareness and the practical side of geotechnical engineering and geohazard engineering as well. So thank you. So a little bit about me. I'm a civil engineer, about 15 years experience. Initially a mechanical engineer, and I like dabbling in like architectural. So I was more moving to structural engineering, and 'cause you see everything above ground, bridges, a lot of tall buildings and skyscrapers. So not too much about geotechnical engineering because it's all below ground, right? It's really hard to see that. So started moving into civil engineering, and I was doing drafting at first, doing a lot of architectural drafting and mechanical drafting, and then I moved to civil drafting, and then started out in soil investigations, so doing a lot of logging, a lot of instrumentation and data monitoring. And then started playing with soils, and then I really liked it, especially the geology side of it as well. And being a geotechnical engineer, you don't get to, deal with too many rocks, or rock characterization. So I really liked the geological processes of things, and yeah, so that really sparked my interest in being out in the field. And as a geotech engineer, being able to use a rock hammer, how cool is that? So yeah, right. So, really, really cool. And it's nice too. Now I get to teach some of our younger staff, our younger geologists, about geological engineering, which is really cool coming from a civil and geotechnical engineer. So, um, yeah, so I've been doing geotechnical engineering, like I said, for about 15 years, but really focusing on geohazard engineering, which is a new kind of category or subcategory of geotechnical engineering, which really hasn't been a very popular subject in the last about 20 years. So,
Okay, so kind of niche within a niche within a niche almost.
yeah, yeah, and not many geotechs are competent or know about geohazard engineering. It's mostly a lot of like deep foundations, cut
Yeah.
and fill, road work, embankments. So yeah, it's been very interesting. I really like it, and I get to be out in the field a lot too, which is really cool. Nice aspect of geotechnical engineering.
You've worked on post-wildfire debris flows. What's your biggest misconception people have about how these disasters unfold?
I think the biggest misconception is that a debris flow won't happen. So we've had a lot of circumstances of where post wildfires happen, right? And that's a natural disaster, especially in like California. I mean, post wildfire is like a norm, a normalized thing now in California when it never used to be. So people don't believe that these debris flow events will happen. So there's not a lot of proactive mitigation and efforts for debris flow potential. So, I think the biggest misconception is that these debris flow events won't happen, or it's not, it won't be catastrophic. So there's not a lot of there's not a lot of emphasis on debris flow potential.
Sure, what's the process of mitigating something like a landslide or a rockfall after a fire has stripped away the landscape?
So the process is actually very interesting. The state of California, for instance, they have put together a team of a bunch of engineers and geologists that are professionals in the field. And after a fire, they go out and do their field mappings. They'll go look at these watersheds and these drainages. and they'll figure out, well, first off, how much of the watershed's been burned. Because once the watershed's burned, you have all of that debris, all of that ash. You have no root stabilization in your soil, especially on these soil slopes, like in the hills above Montecito. There's just a lot of soil strata that's above the bedrock, and then from there, with all the roots gone, all that root structure, that soil is it's sitting there ready to come down. It just has no strength. So the biggest thing is going out, looking at the watershed, figuring out how much of that watershed has a potential for debris flow, and then from there, figuring out when is your next rainstorm. Because that's what's going to trigger these debris flow events. Is what kind of rainstorm and intensity do you need in order to make this debris flow happen?
Okay, when you say watershed, do you mean water table?
No, no. So watershed in like California and especially on the West Coast. I don't know if the East Coast has the same like terminology for it, but it's like your tributary area. Like what area can contribute to a debris flow mass? Yeah, like over in New Mexico, for instance, Michael, watershed is basically it's very like a protected area where the watershed contributes a lot to the drinking water. For instance, like Las Vegas, New Mexico, the watershed over there was burned a couple years ago from a fire, and that's where they get all their drinking water from. They have a lot of natural springs. So they look at this watershed area that they do get a lot of accumulation of rainfall that runs off into their reservoirs and then into their dams, and then they can storage that water for future use. So they kind of look at that because water is everything now. It's really how do you purify it and how do you keep it clean, especially from debris flows. It can really mess things up.
Struggling to find top geotechnical and geoenvironmental talent? You could use a generalist recruiter, or you could use a specialist. At Geo Expert Search, we place experts where they belong. Across the UK, USA, Australia, and New Zealand. No highways, no bridges, no structures. Just geotechnical and geoenvironmental. Now and forever. Geo Expert Search. Finding the right people for the right roles with no wasted time. Visit geoexpertsearch.com to learn more.
Okay, so are we getting better at predicting or managing the geohazards, or is it still a case of just kind of reacting to them?
I think that's a great question. I think right now we are getting better and being more proactive to debris flow and post wildfire events. I think with social media being a huge presence now in today's society, you have a lot of videos. People are taking, on their iPhones, taking videos of landslides and debris flow events. And especially with this wildfire in Pacific Palisades in California, it's all over the news. So social media has brought a lot of light to this, and a lot of people are knowing more about these geohazard events, specifically relating to debris flow. So there's definitely been a more proactive approach. One of them is like alert or warning systems. So, for instance, they will, like Montecito, for instance, had a warning system uh, that alerted when a debris flow potential was a possibility. So there's a lot of warning systems being installed, especially for avalanche too, which is another big one, especially up north in the state of Washington, going up into Canada. Avalanches are a huge thing up there. You have a lot of snowpack, so they have a lot of warning systems for avalanches. So we're trying to do more of that for debris flow here in
Nice. Okay, so in terms of mitigating the risk of potential debris flows, then it, what's the kind of process of doing that? Because I suppose there's so many different areas which can be prone to it. You can't proactively solve the problem before it begins everywhere because there's budgetary constraints and everything else. So what's the kind of process? I wonder if you can tell us a little bit about that.
Hmm, that's actually a really good question. So typically with debris flow modeling, when you start to model these debris flows, you start looking at risk assessment, which would be one is there a risk to human life, right? Which is the number one thing for engineers, right? Is to protect human life. So that's the biggest thing. And then critical infrastructure, roads, bridges. Can these things get wiped out to the point of where now this critical life can't move out of these areas? So that was a huge thing over in North Carolina, for instance, when they had their large rainstorms this last year. A lot of their roadway and infrastructure got wiped out, and it wasn't meant for those long lasting landslides and mud flows. So one of the things over there in North Carolina was that a lot of the construction equipment couldn't get in because all of these roads are like wiped out, meaning a lot of individuals cannot get out of that area as well. So so looking at the risk, it would be one is what is the impact to human life. Second would be what is the impact to critical infrastructure, and then third would be of course residential buildings. So a lot of these homeowners don't have funds to rebuild. A lot of these homes, especially in Montecito, uh, uh, going towards the coast. I mean, you're talking about millions of dollars to rebuild your house. Well, how do you come up with those funds, especially if you don't have insurance?
Which is another point, wasn't it? Because some insurance companies had kind of walked away. So
Hmm.
yeah, who knows what position some people will be in relation to that.
Yeah.
I think even your president name checked one of the
Yeah.
insurance companies, which
Yeah.
I'd imagine they had a lot less customers after that. Um, but yeah, that's an interesting kind of side to it. In the UK, of course, we don't have that as much as maybe I'm thinking of the local area where there's kind of risk of flooding, and a lot of the insurance companies have just said no, we're not going to insure the area, or if it is, the money, the policy is going to be so expensive, it forces people, just everyday working people, to not actually be able to afford it. And when it happens, it's just a huge disaster, and they build more and more on floodplains. It's a nice kind of area, it's nice kind of flat, uh, but
Hmm.
when it floods, then there's huge problems for people.
Yeah. I I think too. Going back over to Europe and on the topic of geohazards for Europe, I think like Switzerland, for instance, a lot of geohazard. There's a company, GeoBrug, out of Switzerland, and they've kind of pioneered a lot of debris flow mitigation uh, structures that you can use to mitigate debris flow events. Because Switzerland has such high topography, in these really really low valleys, that Switzerland is like a geohazard central in terms of rockfall and debris flow and slope stability. And I've gone to Switzerland a couple times just on leisure, but also going to a couple of geo groups. They have these things called Geo Summit, where they invite a bunch of professionals all around the world. We go over there and they give us a tour of just the beautiful area of like Davos, or we stayed near Zurich, and you could see just the terrain over there and what they have to deal with. And they've kind of pioneered a lot of this geohazard mitigation to where now we're really starting to use it in the States. So it's just very interesting the contrast of how much emphasis that they put on geohazard engineering, especially over in Italy as well. And and there's a lot of companies over there that monitor for geohazards. There's one called GeoPrevent, and they have monitoring systems that shut down roadways, kind of like a railroad track. When these rails travel on all these rail cars and on these railroads, you have to close those roads because you don't want people going through and trying to second guess that, right? So that's what they're doing in Switzerland, is they're creating these like automated systems that within seconds of acknowledging data or a or like an issue that that they shut down these roads. So such a huge emphasis for Europe on geohazards that that America is starting to kind of implement, which is great. We kind of need to look at Europe in terms of how they are doing things, because that's one thing that we could do better in the US.
So if you had an unlimited budget in maybe technology, how would you revolutionize geohazard mitigation?
Mm. I think one would be more data monitoring. Data is everything, right? People like to collect data, right? I think one of it is creating these remote monitoring like programs. There has to be a way where we can collectively come up with a monitoring system to where we know for instance, for like a debris flow, it's like if you have a rain gauge or like a rain sensor, right, that collects rainfall information. You have that high up, let's say on like the top of a mountain, and in that area it collects all the rainfall. So therefore, you have a high intensity, uh, like rainfall event high up. You have soil moisture data sensors that, okay, your soil is starting to get saturated, it's starting to exceed its critical limit. And then you have different, maybe like radar, like some sort of radar that reads within channels to where you can figure out, okay, a debris flow is moving down, and then you can have some sort of warning system near local, residents and stuff like that, so they can evacuate. So I think there's a way you can incorporate all those different types of techniques, and you could put it, we have, for instance, in California, we have a huge emphasis on earthquake engineering, right? So like whenever there's an earthquake, you can get an alert on your phone, of like an earthquake down in Southern California or San Francisco in the Bay Area, but we don't have that for debris flow events, right? So that would be something, if I had an unlimited budget, it'd be something like that, where you could have a mass um, uh, data monitoring and alert system for debris flow events where you can get it on your phone.
So when a project goes over budget, how often is the ground itself to blame?
Actually, that's a very interesting question, Michael. It's typically not. So soil itself, you can do a lot of characterization of soils, and you can take soil samples here in like California, or you can take them over on the East Coast. Of course, they're going to be different, but as like geotechnical engineers and having a level of like competence, you can kind of make critical engineering judgments on different soil like classifications. I think the biggest thing on soils is just the cost overruns from review processes, from permitting requirements, a lot of review, too many people looking at this project, spending too much time. But the actual soil itself, actually, it doesn't take that much additional work. Um, so yeah, I'd say soils actually don't contribute additional overruns to it. Now there might be some areas. I'd say one thing on that is not knowing where you have a change in strata. So for instance, with landslides, is you might do let's say that you have a slope that's 100 feet tall. It's pretty steep, and you don't exactly know where that bedrock interface is. So, you do a boring at the top of the slope, right? A vertical boring. You do a vertical boring at the bottom. That's kind of typical. Not many drillers drill, horizontally into a slope and take cores or take any kind of soil samples. So I think, when people go to map, what I mean, where that soil bedrock interface is, there's always that question mark line. Well, maybe it's right about here. So I think, if there's some sort of implementation of doing horizontal drilling where you can take soil samples, especially if you know you're going to work on that hillside, then that's huge because you know how thick that, for instance, let's say you have colluvium on your slope, then you know how thick that colluvial layer is over that bedrock, because that colluvial is just not going to give you any strength, but you're going to get a lot more strength in that bedrock. So that not too much relating to debris flow, but geohazards in general, especially to landslides, is pretty great.
Sure. So are developers and contractors investing enough in the ground investigation stage up front, or is it still, considered an afterthought?
I think contractors are being more aware of it. We actually have a couple projects currently in proposal phase of doing a bunch of debris flow work down in Southern California after the Pacific Palisades fire. So there's a lot of contractors, looking to be proactive rather than reactive on the post-wildfire mitigation. But I think a lot of the developers are not as um, proactive. Especially a lot of these developers are looking to build all these communities on these hillsides. They're not looking at the long-term effects of stability of your hills, or you could have a debris flow potential in this channel. They're just looking at just building and getting out of it. What can they do to go build, get the building permit, and then just sell the property?
Yeah, that's it. It's I suppose they're driven by money, and
Hmm.
the ground investigation can seem as if it's a waste of money, but once you do a ground investigation, that's really the only time when you actually know, okay, well maybe we could have spent a bit less. But until you do it and you do enough boreholes and trial pits, that sort of
Hmm.
thing, then it's difficult to know. So
Yeah, we I was going to say, very interesting that you mentioned that, because we have a project over in Colorado, near Aspen, Colorado, and it's in a county called Pickens County. Well, Pickens County has now said, hey, you have to do any kind of like building, because Colorado is just, a lot of people are moving out to Colorado from California, all over the world, just because land is so much cheaper there. It's beautiful out there, it's just very scenic. And a lot of people are moving out there, so there's a lot of building going on in Colorado. Well, they're building everywhere, and there's some places that are not very good to build, right? So, we're working on a project in Aspen, and it's for this very huge development. And one of the things that Pickens County said was, hey, we would like for you to do a soils investigation and debris flow modeling before you do any kind of building and before you get a building permit. And initially, I don't think there was too much emphasis on it. Like you said, it was like, this is just kind of a waste, right? We have a bunch of soils reports back from the 80s. Nothing's really changed. So, very interesting enough, though, is another company went and did the soils investigation, and they found out that in the area where they want to build, there's actually evidence of past debris flow events. So they were able to go back and date these past debris flow events. And it was very interesting because Pickens County said, well, there you go. Like, that's our prime thing is, you had debris flow events past, way back when, these historical debris flow events, and you need to mitigate for this. We're not doing this just to do it. It's, what what are the potential hazards associated with this site? Because sometimes there's a lot of uncertainty, and you have to make sure to minimize and limit that uncertainty.
so what would you say is the best way to avoid costly surprises?
Costly surprises, I would say, is definitely do a soils investigation, whether it be a visual observation. Like, for instance, there's some rock slopes that you can go and look at. And of course, you can do a visual observation. You can go out there, you can do your kinematic study, what I mean, just visually looking at it. And then, if it's a soil, of course, you want to take some soil samples, and soil is very susceptible to different, altering variations, especially with groundwater. So, uh, I would say yes, definitely have to do more soils investigations, because there's just so much uncertainty in things, especially people that want to build way out in the middle of nowhere, and nothing's ever been done in these areas, and there's just no historical records of anything in those areas, especially faults, right? Faults is a huge thing, especially in Southern California. It's like, a lot of geologists now are doing fault studies in Southern California, finding all these new faults, which is critical, because a lot of people don't know that they're in an earthquake or a landslide susceptible area until you find those faults.
Yeah, and you can't on some of the things. I think if a developer goes out, looks at a lovely, nice green field, it looks It's really nice, but until you kind of drill into it and then you find that it's maybe it's caustic or maybe it has a load of contaminants which you have no idea of at that point, or some mine workings.
Exactly.
There's been, I mean, there's lots of instances worldwide where someone's bought something that's a great deal and then actually they've had to use grout and grout up some mine workings or whatever it may be, but it's not as it
Mhm.
first appears, potentially at least. So, with
Oh, yeah.
extreme weather becoming more common, are we designing infrastructure that's ready?
Y- yes, I would say yes, we are. In terms of debris flows, I would say there is more emphasis on mitigation structures for debris flows. And for debris basins as well. The only issue with debris basins is you have to have a lot of real estate for them because they're so large, right? So a debris basin is basically just an open pit area where the debris flow can move in and kind of uh, uh, has a deposition area where it can deposit itself. You can go and clean it out later. But yeah, there's starting to be a lot more proactive measures on debris flow mitigation, and people are starting to put it more in their bids, RFPs, and so forth for future work.
Okay, so are you seeing innovative materials or construction methods that help us adapt to changing environments?
Yes. Oh, totally. Yes. Um, I think one of the biggest things is corrosion. So, especially on the over in Hawaii, everything over there, corrodes so fast in terms of you just have all that salt, uh, all the seawater. So everything corrodes pretty quick, especially if it's not even galvanized, any kind of corrosion protection. So a lot of stuff over in Hawaii has to be stainless steel. So over time, we've kind of learned, hey, let's use different types of corrosion protection and see if this works, right? So stainless steel is great, but it's really costly. In terms of debris flows, we have over time, especially working with a lot of contractors. I know there's been a couple contractors on the show in the geohazard industry, and especially working with like contractors on different techniques to try to help them out in the field. One of them is drilling, different kind of drilling techniques. How do you keep a hole open in colluvium? If your holes are collapsing, how do you keep those open? Uh, a couple other things are we've actually come up with a new design process for debris flow barriers here at Kane called a SVX system, which is where we've eliminated posts and streams, these steel posts that hold up these debris nets. And the reason for that is, especially in California, there's a huge environmental movement in terms of doing CEQA analysis, which are environmental quality control acts, where you have to go and look at the wildlife in the area. How much of the land are you going to disturb? So there's been a lot of emphasis on that. So we've had to work with a lot of environmentalists and biologists to figure out a way that we can do low impact in these areas where we build mitigation structures, which has been huge because then it helps the contractor out and to determine, okay, what kind of equipment do they need? How do they budget these things? So we've definitely learned a lot from contractors, and I think contractors have learned a lot from us as well and what we can provide to them.
So, what's one major thing in the industry should be doing right now but isn't?
One thing in the industry should be doing right now, but isn't probably providing more papers or research in geohazards. There's so many papers and research on earthquake engineering. It's all over the place. It's huge, but geohazards is just not as much. There's a bunch of different societies and committees in California and in the U.S. One of them is the Highway Geology Symposium (HGS), and they actually have a bunch of they have a symposium every year, and we're actually giving a couple papers this year, and they actually have in there that they'd like topics on geohazard engineering, for debris flow, rockfall, avalanche. What are some mitigation techniques, ground improvements? So I think putting out a lot of these publications and papers really helps, especially people that really like to read and understand things, and a lot of presentations too. I think presentations are critical because a lot of people don't want to read, or uh, look at these research papers, right, with all these mathematical equations. I get it, and everything's online, everything's social media and videos. So I think if there was more of a social media presence to, I don't know, maybe like a TikTok channel or something on geohazard. I don't know, right? But I mean, that's how you're going to get to a lot of these uh, individuals. You know what I mean? That are not, for instance, reading books, or maybe going to these symposiums and kind of get them going on geohazard uh, awareness and also on geohazard engineering.
It's interesting you mention that, because you're right. If it's a paper or presentation, then how many people are going to read it? How many people are going to see it? Versus how many people scroll through LinkedIn on a daily basis. And you've
Right?
got the power of video editing, music behind it, and it's the power of doing that, which would reach a larger audience by far.
Yeah.
So is
Well,
there
even
not?
like,
Sorry, go on.
oh, sorry. I was gonna say, even like your podcast. I mean, that's huge, right? Because some people, have to drive for work a couple hours, So by putting your podcast on and the background, they get to learn a lot about different geotechnical techniques and geotechnical engineering. Maybe they might be a structural engineer that's very interested in your podcast. So that's
Yeah.
huge, right? So that's something that's very innovative that you are doing and putting awareness to.
So in terms of papers and presentations, do you think there is enough people in your world who are producing them, who are taking the time out to write and to present?
I think so. For instance, personally, I'm not much on papers. I do like to kind of talk and chit chat and give presentations, but papers, I'm not much on papers. But I think there is a lot of individuals that are putting out papers and presentations, and I think one thing that really helps is that there's a lot of individuals at these larger geotechnical companies as well, that are, maybe a small category of that company, but they're going out of their way, learning a new topic. Maybe they're looking at some of our publications from back in the early 90s and adapting to that. So I think there's a lot of individuals that are bringing more awareness to this. They're, for instance, the HGS this year. There's so many categories, and typically there's a lot of different engineers from different firms that are attending these things, that have different techniques that you're talking about in geohazard engineering. So I think there's a lot of awareness to it.
Okay, so you've worked with slope stabilization and rockfall barriers. What's a project where failure taught you something critical?
Ooh, I would say we had a project about 2 years ago, and it was a project down in Bakersfield, California, which is out in the middle of nowhere, and it was for a hydroelectric dam. And it's a terrible place to put a dam in terms of you have all these geohazards in this area, but it's the best place for a dam because you just have such high flow. I mean the water is just flowing through the river there, and it's the best place for it. So the project, a little background on it, they had a huge rockfall event back in about 2016, and it impacted the dam. Well, it impacted the dam so much that they had to shut it down for repairs. Well, when a dam is getting shut down, it's not generating any income, right? It's not generating any electricity. It's not doing anything. So you're actually losing on that side. So a the client reached out to us and said, "Hey, can you guys do a mitigation design to stabilize this hillside?" And we're like, "I don't think you're going to stabilize this hillside. I mean, the slope goes up, probably about a quarter of a mile, and it's just full of rock." And we're saying, "Well, but you can put different types of mitigation structures to prevent, or to minimalize the rockfall event." And so we did a design, and one of the things that we didn't account for was the rockfall event actually turned more into like a rock slide. It was this huge rock slide, and we really didn't. When we did our design, of course, you have factors of safety involved, and we looked at the amount of debris, but we didn't assume that it would all come down in one slide. So that was one thing that we're going, oh man, I'm glad that worked, But no, but everything worked out good. There were some maintenance on our mitigation structures, um, but in the end, the client was really happy, and we said, "Well, why are you happy? You know what I mean? You got to do a bunch of repairs." Because I don't know, I'm happy because my dam stayed open, even though we had this rockfall event, and we have some repairs to the rockfall infrastructure. My dam stayed open, so I'm still generating revenue. I'm still supplying electricity. So even though it wasn't a failure, it's something that we could improve on, and we actually did that this year. The client said, "Hey, how can we improve on this?" So what she did the first time was great, but let's improve on this. So a couple of our engineers got together, went out there a bunch of times, flew our drones out there, did a bunch of mapping, and we came up with this huge attenuator system. It was like 300 feet long and about 300 feet high, and it's massive. It looks like a bridge span of like wire rows. So it was very innovative, and it's the first time I think that we've done something like that. So very very cool. So even though it wasn't a failure, we improved on it, and the end client was very satisfied with it.
Okay. So are there any common mistakes that you see in geotechnical design that keep repeating?
Yes, I would say a couple of them are um, not knowing or being too conservative on things in terms of geotechnical engineering. Like for instance, with ground anchors, ground anchors in rock. There's a bunch of publications that are out there on ground anchors in rock that have bond strength values that different organizations have tested. They have different data ranges, and then you get a report from an engineer that has these really really low values, and you're going, well, where did this number come from? There's no justification for it other than it is engineering judgment, right? So maybe the engineer felt that he was comfortable at that time, right, based off his engineering judgment, and there's always judgment in things. But you could hire somebody else to review your work and go, hey, what do you think of this? Maybe I'm not as competent in this field. What do you think? There's a lot of engineers that kind of don't know much about geohazard engineering. So they could reach out to us and go, hey, we're not as competent in geohazard engineering. Can you guys look at this? Can you guys do this? Which is great. So we work with a lot of these other geotechnical engineers to help them. We have a couple of projects going now, the largest geotech firm down in Southern California, and we actually partnered with them to do the slope repair and the slope stabilization work because they just weren't as competent in it, which is fine. You know what I mean? You can only be competent in so many things, right? So they hired us, and it's turned out to be a great project, and we've been able to collab a lot on that. So I think it's just too many engineers. Going back to your question, Michael, I think it was just too. There are some engineers that are too conservative on things that they don't realize that there's a cost associated with that too.
Sure. So if she was to be overly conservative and it increased the cost, is there any is there any kind of occasions where you'd perhaps get in touch with whoever done the design and alter the design just by saying that this is ridiculously over conservative design? Do you think you should look at it again?
We have, and I'll give you both sides of that. So we have some people that are a little more, I would say, willing to go and look at it. Say, okay, hey, like, thank you for looking at this, doing a peer review on this, which that's great. I mean, that's another thing too is, every time you submit plans or you submit calculations, you should always have somebody look at your stuff. right? Just to do a validation, measure twice, cut once, right? Because, I mean, we're all human. We all make mistakes, right? So it's nice that somebody can look at this. So, you do have some engineers that are more, okay to, hey, can you look at this? Oh, great, and add that value engineering. And then you have some engineers that are not as like, oh, what are you doing criticizing my work? It's like, whoa, 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 we're not criticizing. We're trying to help you
An
here.
ego
They're
thing.
like, no, you're, yeah. So there's both sides of it.
Yeah, I would imagine. Yeah, it depends on the personality type potentially, doesn't it? But
Yeah.
okay. So, what's your biggest oh no moment in the field?
Uh, my biggest oh no moment. Oh, oh, the oh no moment. Okay. We had a project, and it was for these ground anchors to be installed into granite. And they were about 9 foot anchors. I mean, they didn't have much load on them, and we designed them adequately. Well, turns out that the anchors near the bottom of the slope, there was like a buildup of talus. So there was a bunch of talus that was overlaying the more competent granite rock. So it was a bunch of like DG. And so when we were out on site, the contractor was already, set up, ready to pull on this anchor. Didn't even ask us though where they wanted to pull. Of course, they want to pull on the easiest one. So we're like, okay, let's pull on this, and if it works, then great. If not, then we'll, figure stuff out. Well, we pulled on the anchor, and the anchor pulled out immediately. Yeah, I mean, it pulled out within probably had like 5 kips on it, and it was already moving. Like, oh crap, this thing's supposed to take like 50 kips of load. You're like 5% of that load. So, and then we asked the driller, because we weren't out there during drilling, and we asked the driller, he said, hey, did you hit any competent granite? He goes, oh yeah. Oh yeah, it was all hard stuff. I'm like, well, is it hard stuff or is it granite? Like, did you look at the cuttings or or like anything, And he goes, oh, yeah, it was granite. It went 9 feet, and we are like, well, did you go 9 feet into granite? And he goes, no, I went 9 feet total. So it turns out it was about 7 feet of talus and 2 feet in competent granite. So that's why it pulled out. So but there were a lot of other engineers on the job site looking at this thing, and they're going, "Oh man, what happened? Oh, failed anchor." We're like, "No, no, no, hold on. It's just, miscommunication on this." So they moved all the talus and cut it all back like they were supposed to, and then we put the anchors into competent granite, and they held up fine after our second test. So that was my oh crap moment.
In terms of drillers, what's the kind of relationship between drillers and engineers?
Drillers and engineers, I'd say more soil drilling, like a lot of those drilling companies that have like hollow stem augers and large, vertical drilling augers. I think they understand a little bit more on what the engineer needs in terms of doing blow counts or getting samples. They're a little bit more um, cognizant on helping out the engineer on correcting blow counts, or if there's questions out there, they're more open to that. I think on if you're just a driller, like have just a guy with a rock drill. I think they definitely understand drilling techniques better in terms of keeping holes open, how to drill in a really, really let's say thick clay or something, where a lot of people don't like drilling through clays because it clogs up drill steel and so forth. So there's a lot of experienced drillers. So I say that there's difference in both, but I say both of them very they both like working with engineers. I say that, and soil drillers tend to be more knowledgeable of geotechnical engineering, like sampling and so forth, but more of like rock drillers understand more of the geology, or more of the practical engineering.
So with the soil drillers, let's say you're out on site, soil drillers, correct me if I'm wrong here, so it would tend to be logged on site by the engineer. Would that be right?
Mhm.
And
Yes.
perhaps the rock would Would it be taken away? Would it be logged on site, or certainly more likely to be taken away? Is it to a kind of like a logging shed, is what we'd call here?
Yeah, yeah. We actually had one of our geologists up in Oregon just this last week, and he was up there. They actually did rock coring on site, so they did hollow stem, then they swapped to rock coring, and then from the rock cores, we were able to determine the rock quality designation and the recovery, on site. So, uh, and they're pretty good, handling samples. You know what I mean? And opening up sampling tubes, so they're pretty good about that on site. We've actually had a good experience with a lot of drillers. We've really never had a bad experience. I think ground conditions, trying to get a drill onto a site, let's say the ground's just really, really wet and they just can't get their drill out there, that's one thing. But actually drilling down into the ground, we've had a good experience with the drillers.
Yeah, no, a wet bogged down field can make for a fun kind of ground investigation. I've been there
Right.
myself, where there's kind of a Land Rover has got a drilling rig on it, and it gets about 50 meters in the field. That's it.
Hmm.
But you have
I
to.
think too
um,
is a lot of drillers have respect for engineers that stand next to the drill. I'm over there looking at the cut-ins, and some engineers they're like a mile back. I'm like, what are you doing? They're like, oh, I'm watching the drilling. I'm like, now you gotta get up close and personal. Put your, when they're done drilling, look at those cuttings because it'll tell you a lot. They, it's like get up there and get some of that mud on you. Get that hard hat.
you don't get much respect from the driller if you're hiding in a van.
No, no, none at all.
No, it's definitely different. Do you think we'll get to a point where AI and automated systems can predict failures before they happen in relation to geohazards?
Yes. I think it will get to a point where AI can determine and have triggers. I mean, we're kind of already there, you know what I mean? And just putting together systems with alert and uh, warning threshold. So I think there will be a time where AI could probably write code uh, and determine its own triggers and warnings, which that would be great. I think that would really help out. I think AI could be a great thing, a good and bad thing, right? Because there's good and bad to everything. But I think AI could have a good influence in data awareness and data, especially remote monitoring and warning systems.
Do you think you ever get a kind of automated drill out in the field with kind of maybe a Tesla robot operated by AI? Is it completely replace everyone? Do you think that'll happen?
Ooh, that would be interesting,
It
huh? I
would be
never thought
interesting.
about that.
I
Yeah, that'd
wonder.
be really interesting.
It
Yeah,
could,
how efficient would it be?
yeah. Well, I mean, unless the field was boggy, I suppose it would have to have
Yeah,
water or something,
right.
wouldn't it? Then it would all fall down.
Yeah,
Okay, so
right. Yeah.
so Joseph, if someone wants to work in a space and tackle the kinds of problems you do, what advice would you give them?
I would say, in the space that I'm in and in the geohazards field, I would say, especially to engineers and civil and geotechnical engineers, is learn a little bit about geology if you have a chance. Because, in I gave a class or I gave a presentation to a geotech class last week at a local university here and I told him, I said, usually in your undergrad classes, you learn about soil, and then once you get the rock, everything's fine. And it's like that's not true, And it's like you can have fractured rock, you can have jointed, really, really weathered rock. There's all different types of variations of rock. So I'd say with like engineers is learn a little bit about geology or geological engineering, and then the same thing with geologists. I'd say on that side is for geologists to learn more about the engineering geology side, and I think that helps out a lot too in the field of geohazard engineering.
Yeah, it definitely helps to appreciate what the kind of
Hmm.
information that your colleagues are looking at in order to make the decisions.
Oh yeah.
Because I suppose if you don't, you might think, why would we need to do that and not fully appreciate it?
Oh,
But
yeah.
that's it for today. If you've liked this, share it with a colleague who needs to hear about geotech innovations, disasters, and how to keep the ground from giving away beneath us. Subscribe if you've liked it. If you don't like it, subscribe even more. I'll see you next time. Joseph, thank you very much for your time today. I do appreciate it.
Hey, thank you, Michael, and thank you for bringing awareness to these geotechnical issues.